let me explain about the pigment binder ratio. Pigment binder ratio. Then there is an important term called oil absorption, and we should know something about the pigment volume concentration and critical pigment volume concentration. So these are all the important parameters which are very frequently used in formulation, paint formulation. So let us study this deeply. We know the paint is nothing but pigment plus binder and it needs some additives. Along with that, we used to add thinners, a combination of or mixture of solvents. So here the pigment binder that decides the quality and the type of finish also. And additives are added in small quantities for a particular purpose, and thinner to adjust the viscosity and to obtain a better that is type of application also. For example, if it is a spray type or dip type or brush type, we have to adjust the viscosity using this thinner. Thinner is a blend of solvents. Now let me talk about this pigment binder. As I already initiated with the pigment binder, so pigment binder ratio is very important. So here the oil absorption is a very important term. Oil absorption is a very important term. It is nothing but the quantity of oil, the amount of oil, you can say, quantity of oil, the quantity of oil required just to wet the pigment. Okay, just to wet the pigment. And for example, let me consider chalk powder and talcum powder or face powder. So this is very fine, whereas chalk powder is coarser. Now let me mix with a binder. In fact, it would be easy to wet the chalk powder with certain amount of binder, but wetting the talcum powder is a tough job because of poor wettability. Why this poor wettability? Because of fineness, the degree of fineness, or the particle size is very fine. In this case, it is coarser. So finer the particle size, greater will be the surface area, and that is why, so we can mark like this: finer the particle size. Finer means you are reducing the particle size. Finer the particle size. What do you mean by that? Particle size. Finer the particle size means, that is, I am reducing the particle size. Particle size, and greater will be the surface area, and thereby the wettability also increases. That is, ease of wettability will be difficult. Okay, decreases. Wettability decreases. You cannot easily wet. So, based on the selection of pigment, you have to Consider essentially the oil absorption, as I already mentioned, the amount of oil required to wet the given quantity, given amount of what? The oil. And in the case of, because we are using enamel paint, enamel and water-based paints, emulsion paint, water-based paint. So in the case of emulsion paint, in the case of water-based paint, we had to consider the water absorption. Usually it is given as index. And here in the case of enamel, that is oil-based enamels, we use this term, that is oil absorption, you can call it index. It is given as a percentage also, or as an index value. For example, if you take talc, the oil absorption index will be 30, but the same talc, the WAI is around 34. If you take, that is calcium carbonate, calcite, CaCO3, and let me take 1 micron, micronized, very fine. In that case, it requires, that is 19 grams to wet the surface, that is 19 is the oil absorption. And titanium dioxide, TiO2, titanium dioxide. So its oil absorption. Now let me define more on this subject rather than the water absorption index. So titanium dioxide, it is around 25. Then black iron oxide, black iron oxide, and for which it is 16 is the oil absorption. And similarly for chrome oxides, it will be 10. And for red oxide, it is 23. So likewise, we have got different values for different types of pigment based on the coarseness and the nature. This is 23. If it is a ultramarine blue, the value is around 16. Now let us discuss about the pigment volume concentration. That is a very important parameter in paint formulation. PVC and critical pigment volume concentration. So PVC is nothing but the ratio between the volume of pigment divided by the volume of pigment plus the volume of the resin. This is a very important formula. So VP means volume of pigment and VR means volume of resin. You know, the density is nothing but mass by volume. So, using or knowing the value of density, the volume of pigment can be obtained. So, volume is equal to mass divided by density. Are you able to follow? Mass divided by density. So this formula can be effectively used for determining the volume of pigment. Let me go slowly, step by step. Critical pigment volume concentration. So this is PVC, pigment volume concentration, that is volume of the pigment divided by the total volume of pigment and the resin. As we already seen, we consider only the pigment and the resin. Resin is also in this case known as binder. So pigment plus resin, these are the two major ingredients in paint. So what could be the volume of the pigment in the total volume of pigment and resin? So that is the concentration of pigment, that is pigment volume concentration. I hope now it is pretty clear. CPVC means critical pigment volume concentration. It is the point which the right amount of binder is present. The right amount of pigment, the right amount of binder, the right amount of binder which can soak all pigment particles. And fill all the existing gaps. Okay, in other words, it represents the for example, it is a kind of circumstance in which almost let us assume the pigmented or the paint has 100% coverage devoid of all gaps. That is, there is no gap at all. Let us assume like this. For example, let me illustrate further on this topic. See, let me call it this as the binder and this as pigment, and this is YAB. So this is binder, this is pigment, this is YAB. Let us assume like this. Now, when the pigment volume concentration is less than critical pigment volume concentration, it means you have got the binder. So the binder consists of what? The pigment with various particle size like this. Okay. So here the pigment volume concentration is less rather than the binder volume. So this is the binder and this is the pigment. I hope by this illustration it is very clear. And let us assume pigment volume concentration is equal to critical pigment volume concentration. It means we have a binder surface area and we have got equal amount of pigment volume also. So here we have these are the pigment volumes. So the remaining space or binder. So here the pigment volume and the binder volume is almost the same, and that is why it is called PVC is equal to CPVC. And If there are any air gaps, it means that is a PVC is greater than CPVC, where you can find okay, so these are all the pigment volumes, and besides that you have certain air gaps also. So in that case PVC is greater than CPVC. So when PVC is less than CPVC, now the paint is glossy. Are you able to understand this? The paint is glossy. It means the binder portion is more. The binder ratio is more. Okay, but if there is a more amount of binder, there is a problem of coverage. So you have to strike the balance between this coverage and glossiness.